Okay, so this morning we're going to revise adding and subtracting fractions. A couple of things that you need to be able to do in order to do this is you need to be able to convert from mixed fractions to improper fractions and vice versa. You need to be able to convert from improper back to mixed. So we'll do a couple of examples of those. You should be able to do this because it is revision, but we'll have a look anyway. So say, for instance, we've got something like 7/4 or 2 3/5. So obviously 7/4 is an improper fraction. It means that it's going to be more than 1. So who can remember how we convert that back to a mixed numeral? Ian?
You would divide it by the numerator by the denominator, and without like any decimals, you'd have the remainder stay in the numerator.
Very good, that's right. So what we're looking for, obviously, because it's more than 1, we're looking for a whole number, and then we're looking for a proper fraction. Okay, we don't want, that one would not be an improper fraction because then you've not done it properly. So, one thing about this, for both of them, for converting improper to mixed and converting mixed to improper, the one thing that you can guarantee is that the denominator does not change. Okay, so you're going to have a denominator there and you're going to have a denominator there. The only way it might change is if then you need to simplify it. But when you do your first conversion, the denominator is the same. And just like Ian said, you do how many 4s are there in 7? Well, there's 1, so that's your whole number. And then how many quarters would be left over? There are 3. So 7/4 is 1 3/4. Everyone happy with that? Do you want me to do another example? Let's try one that might need simplifying. Oh no, let's just do 22/7. Okay, so again, we're going to have a whole number and a proper fraction. Same process. How many 7s are there in 22?
3.
3 remainder.
1.
1, good. And then the denominator stays the same, so it's 3 1/7. Everyone remember how to do that? All good? Okay, so this one is slightly different. We're doing the reverse process. Again, no, the denominator stays the same. So this time you've got 2 whole ones. So obviously in 1 whole one there are 5/5, and in 2 whole ones there are going to be 10/5. But the way you do that is you multiply the whole number by the denominator. So 2 times 5 is 10, and then you add the numerator to get the leftover fifths that you need to add in. So 2 times 5 is 10, add 3 is 13. So your answer is 13/5. Okay, so we've got 3 and 2 7ths. We'll do this one. Oh no, 3 and 2 9ths will do. So again, denominator will stay the same, so 9. 3 times 9 is 27, add 2, 29. Okay, so that is 29/9. Is everyone happy with those? You're okay with doing that? Okay, good. I'll rub that out then. So, what we're going to look, the one good thing about addition and subtraction is that once you know how to add, you know how to subtract as well, as long as you remember to subtract the 2 numerators, not add them. Okay, I have had students add them by mistake. So if you've got, I'm assuming, and I won't go over it, that you know how to add fractions with the same denominator. Because basically, if you've got the same denominator, you don't have to do anything with it because you're dealing with the same type of fraction. So it's a bit like, you know, if you've got 3 apples and 3 apples, you've got 6 apples. But if you've got 3 apples and 3 oranges, you've got 6 pieces of fruit. So you've had to change the apples and the oranges into something else in order to say what you've got in total. So let's just start with something fairly straightforward. We'll have a 5th add a 3rd. Now obviously both unit fractions, so that's fine, but it would make no difference even if they weren't unit fractions. So we can't add 5ths and 3rds because they're not the same type of fraction. One of the most common mistakes is that students just add the numerators and add the denominators. and they would put that is 2/8 and then simplify it to a quarter, because they get mixed up once they've learned multiplication, and they get that process mixed up. So you really need to understand what you're doing so that you don't actually mix up the processes. So we need a new denominator. We need to make both fractions the same so that we can just add the numerators. What do we look for when we want the new denominator? What are we looking for? What it's?
Common factor.
You're nearly there.
Highest.
The opposite.
The lowest common multiple.
Yeah, the lowest common multiple, that's right. So you're looking for the lowest common multiple. Now, if you don't know the lowest one, it doesn't actually matter. And actually, multiplying the two denominators does help. I'll show you an example where it doesn't work though. Okay, so here, what would be the lowest common multiple or the lowest common denominator of 5 and 3? First number that appears in both of their tables. 15, that's right. Okay, so 15. Now, if you want to, you can write 15 plus 15. I just put it over one denominator like this because it saves time, okay? Now, if and only if you have multiplied the two denominators to get the new denominator, you can cross-multiply to get the new numerators. If you haven't multiplied the denominators, you can't cross-multiply to get the new numerators, and I'll explain that in a minute. So, because we have multiplied 5 and 3 to make 15, we can just cross-multiply. So we go 1 times 3 is 3, and 5 times 1 is 5, okay? Now we've got the same denominator, so we can just add the numerators, so the answer is 8/15. Okay, you all with me? Okay, good. Let me just show you an example then of when you can't cross-multiply, and you'll see why it works. So, for instance, if we've got something like a half add a quarter. Okay. Now, if we were to do that the same way as we've just done, it would be like this. We'd do 2 times 4 is 8. 1 times 4 is 4. 2 times 1 is 6. Sorry, it's 2. Sorry, I was saying because that's the answer, obviously. And then it comes to 6 over 8, which simplifies to 3/4. Now, how about though, is 8 the lowest common multiple of 2 and 4? It's not, is it? It's 4 is the lowest common multiple. So let's assume that you've thought, oh, okay, the lowest common multiple is 4, okay, and then you get mixed up and you do the cross-multiplying method. You do 1 times 4 is 4, 2 times 1 is 2, so that makes 6/4, which is 1 2/4, which is 1 1/2. Well, that's obviously not correct, is it? That is obviously not correct. So, if you are using the lowest common multiple because you've decided that you'd rather do that, you need to do it in a different method. To be honest, I think the easiest way to do it is to multiply your denominators, and then if you need to simplify later, like we did there, just do it, okay? But if the numbers, you don't want to do that, this is how you do it. So for instance, for a half plus a quarter, your new common denominator will be 4 because that is the lowest common multiple. So this time though, you've got to look at your equivalent fractions. You've got to look at what's happening. So what's happened to the 2 to make it 4? It's been multiplied by 2, so you multiply that by 2. What's happened to the 4 to make it 4? It's been multiplied by 1, so you do that. And then that obviously gives you the 3/4. So can you see the difference between the two methods and why it's really important that you don't mix them up? Good, okay. So there's my border line. So the complications come when we have some sort of mixed numbers. So let's just do, or ones that become more than 1. So let's do something like 2/3 plus 3/7. So what would you do first of all?
Cross multiply.
You wouldn't cross multiply yet. What would you do first? What would you have to find first?
The lowest common multiple.
Yeah, you'd find the new common denominator, which is 21. So you'd multiply those two, okay? And now, because we have multiplied those two to find the new denominator, now we can cross multiply, okay? So 2 times 7 is 14, 3 times 3 is 9, 14 add 9 is 23 over 21. And then what do you do with something like that where your answer is bigger than 1?
Turn it into a mixed fraction.
Well done. So that would be what, Cody?
1 and 2 over 21.
Well done. 1 and 2 over 21. Now, can you notice the way that I'm setting these out? What is really important?
All equal sign in one line.
Yes, you can only have one equal sign in a line, okay? And so that's why they're put underneath each other. So it's a really good way to kind of get yourself into kind of really setting it out neatly. This would be actually incorrect, okay? You can't have more than one equal sign in a line of working. Very important for you later on in maths, but now it's just a good habit to get into, so you need to set it out like this, okay? Now, if we were going to throw some mixed numbers into the mix, let's have a look. So say you've got 2 and a quarter add 3 and 3/5. Okay, now, the method, this is when the method of adding and subtracting is slightly different, okay? If you've got something like this, what I would do is I would take the whole numbers, the 2 and the 3, and I would add them together, which obviously makes 5, and I'd just put them here, kind of like in the bank. We've banked them, and we know we've dealt with them, and then I can deal with them again at the end of the calculation. So now I'm left with just a quarter add 3/5. So then again, new common denominator, which is 20. 1 times 5 is 5. 4 times 3 is 12. So that gives you 17 over 20. And then you can add the 5 back in. So the answer is 5 and 17/20. Now, the only thing there is if this bit came to more than 20, you would have to consider those units as well. So say that came to 21 over 20, your answer would have been 6 and 1/20, because you need, obviously, to change it into an improper, a mixed numeral again. Everyone with me? Is it all are you starting to remember it again now? Good, okay. So let's have a look at subtraction. Now, we'll do a couple of, so we'll have 7/9 subtract 1/3. Okay. Same process. What is my new common denominator?
9.
Right, okay, so let's do it both methods then. So you've got 9 there, 7 over 9 take 1/3. What about if you wanted to do it by multiplying the denominators?
27.
27, that's right, okay. So we'll do it by both methods and you'll see, because obviously here the lowest common multiple is 9. But because we haven't multiplied those, we can't do the cross multiplication method. Okay, this is the one where you look at the equivalent fractions. So what has happened to the 9 to make it 9? It's been multiplied by 1, so we multiply the 7 by 1. What's happened to the 3 to make it 9?
It's been times by 3.
Multiplied by 3, so we multiply that by 3. Don't forget the subtraction sign, not the addition sign. This is the only bit of the process that's different. And then you do 7 take, because they're both ninths now, we can just subtract the numerators, and so our answer is 4 over 9. Now, if you wanted to do it this way, okay, so you'd multiply your 9 and your 3 to get your new denominator of 27. You'd do 7 times 3 is 21, 1 times 9 is 9, that would give you 12 over 27, and then you would just simplify it. So highest common factor of 12 and 27 is 3. That's right. So how many 3s are there in 12? There's 4. How many 3s are there in 27? There's 9. Now, of course, it gives you the same answer. You've just done it a slightly different way. Okay? Now, I don't mind which one you do, as long as you don't mix up the processes. Which one would you, who would do this method? Okay, who would do this method and simplify at the end? Okay, right. So, let's have a look at subtracting some mixed numbers. Now, this is a little bit more complicated. So say, for instance, you've got 3 1/4 subtract 2 1/3. Now, you can't just do 3 take 2 and then bank it. Well, you can actually. You can do 3 take 2 and bank it and then do a 1/4 take 1/3. But what would happen if you did a 1/4 take 1/3? What would happen? It would be negative, that's right. And then, if you're really sure about what you're doing, you can adjust that integer there. However, people do get in a bit of a mess. So I will teach you this method, and when we do negative fractions, you might decide that you want to do that method then, okay? So this is what I would do. I would change both of those into improper fractions. So that one will be 13 over 4, and that one will be 7 over 3. Then I would find my new common denominator, which is 12, because 4 times 3 is 12. Then I'd do my cross-multiplying method. So 13 times 3 is 39, 4 times 7 is 28, 39 take 28 is what? 11? 12. So your answer is 11 over 12. Okay? Now the way you could have done that is you could have done 3 take 2 is 1, and then a 1/4, let's do a 1/4 take 1/3 and see what happens. A 1/4 take 1/3, you'd obviously make your new common denominator 12. 1 times 3 is 3. 4 times 3, 1 is 4. So that comes to negative 1 over 12. Do you see? Now, you've done 3 take 2, which is 1. And then you do the 1 take the 12th, which would give you the 11 twelfths. Okay? When we do negative fractions, you'll have to look at it. So who'd do it this way? Yeah, okay. We'll do that this way for them, but you can do it the other way as well, if you've kind of understood your negative fractions. Okay, you stop there.